So, hello everyone and welcome to our new series of tech-based webinars. Today's topic is Multicore with Berghof and CODESYS. Let's go through the agenda for today's webinar. First, I will give you a short introduction about the speaker, myself, and CODESYS and Berghof Automation and Control Solutions. Then I will provide a little bit info about our devices and the Multicore family. Why Multicore? What are the benefits? The Barcode Duo family, our new Benimis MC-Pi device, and the changes in our software and what makes our Multicore solution a true Multicore solution. After that, I will give you a short showcase of how to set up an application to be multicore and what settings you need and what you need to know. I will do this with our new Benimis MC-Pi device. So let's go to the introduction about myself. My name is Konstantinos Arabatis. I joined Berghof in 2012 as an application engineer for CODESYS V2 and V3. I remained an application engineer until 2015, where I changed to the technical support. Additionally, I was also a trainer, and we're doing customer-based workshops and trainings. And I provide support for all our Berghof controllers, CODESYS V2 and V3, as well as our PowerTrack line of products and remote access. About Berghof Automation and Control Solutions. Who are we? We are a system provider for demanding control tasks in plant engineering and worldwide equipment. Berghof specializes in customized solutions based on a highly flexible standard portfolio, combining maximum fulfillment of requirements with maximum qualitative product safety. The hardware and software components impress with their sophisticated function and maximum reliability, even under extreme loads. This so much about us, and these are the basic applications that we are representing. We provide products for the classic industry and machine building, be it cutting machines, packaging machines, handling machines, transportation machines. We are also, with our PowerTrack lines of products, very much into the intralogistics, where we basically provide control systems for railway guided vehicles for transportation, using an own grinding can solution called a C-can. And also our display devices are often used in building automations. Let's continue with the Multicore family. More power with Multicore. First of all, why Multicore? What are the benefits? Shortly said, we provide a CODESYS Multicore runtime plus a Multicore optimized Berghof real-time operating system. This gives us the benefits on even better real-time properties via independent cores, significant performance gain of overall system, improved visual performance, soft motion applications with more drive. We have double the amount of RAM on the devices that support Multicore, and it is perfectly integrated into our standard device families. So for people that already know our devices, they will see here it's perfectly integrated and you will instantly know how to work with them. Let's go first with our Berghof Duo family. What is the Duo family? Here a quick overview. Basically, whoever knows our product lineup will know these products. We have our display-based controllers, the DC controllers in the Pro and the Prime variant. And for that, we provide now also dual core variants, as well as the compact controllers for the CC Prime and the CC Slim. We call them by the same name and the Duo extension to differentiate between the single core device. Let's take a look at the tech specs for these devices. we have the CC Slim Duo here. It comes with an 800 MHz dual core IMX CPU. It has double the amount of RAM with 512 megabyte. The flash and the retain remains unchanged. We have an integrated RTC, and the case is made of stainless steel, very robust. We have a number of different interfaces and I/O depending on the variant you buy. We can go up to 1 Ethercut and 1 Ethernet, 1 USB port, 4 digital in and 4 digital out. The digital in are also usable as counter and encoders, and we can go up to max 2 CAN, 1 RS485 and 232 combo port, 1 micro SD slot, and 4 analog inputs for voltage and temperature. The default software and protocols that is included with these devices are always the CODESYS Multicore runtime, the CODESYS target visualization, which is provided via a VNC server for the compact controllers, the Ethercut master, and if the PLC is also equipped with a CAN, also the CAN Open master. Optional is, of course, the web visu for additional visualization web-based, and a lot of variety for different features and other fieldbus protocols. We continue with the CC Prime Duo. Again, here we have the 800 MHz dual-core IMX CPU. Depending on the variant, we get either 512 megabyte or 1 gigabyte of RAM, and between 256 and 1 gigabyte of flash. The retain with 100 kilobyte remains the same. Again, we have an RTC included and a metal case with passive cooling. These compact controllers, the Prime has a large number of interfaces, which starts with 1 Ethernet port and 1 Ethercut port. The first Ethernet port here on the left is also always included with the 3-port switch integrated into the device, and 1 USB port, 1 CAN, 1 combi port for serial 232 and 485, 1 dedicated RS485 device, and 1 micro SD slots. We can go up to 16 digital inputs, 16 digital output, 12 analog in, and 6 analog out. Again, our digital inputs can be used either as a counter encoder or also as an interrupt input. The analog inputs support current, voltage, and temperature. Our default softwares and protocols is again the Multicore runtime, the target visu, Ethercut master, and CAN Open master for variants that have the CAN port. Otherwise, a large variety of optional features and softwares. Let's continue to our B-Premise DC Pro and DC Prime. These are our display devices. We provide them from 4.3 to 50.8 inches of display size in either resistive or capacitive touchscreen. This is the difference between Pro and Prime. Here, again, we have an 800 megahertz dual-core IMX, depending on the model, either 512 or 1 gigabyte of RAM, and depending on the model, 256 and up to 2 gigabyte of flash. 100 kilobyte of RAM, RTC included, and basically the same interfaces that we also have on the CC Slim. 1 Ethernet port, 1 Ethercut port, depending on the model, 2 USB ports, 4 digital in, 4 digital out. Again, usable as counter encoder, or interrupt for the Prime, and max 2 CAN, 1 serial combi port, 1 micro SD card slot, and 4 analog in. The software protocols that come by default are as the other devices, with the Multicore runtime target visualization that is displayed here on the device itself, not via VNC server, Ethercut master, CAN Open master, and as well as all of the options. Let's continue with our new and upcoming Benimis MC Pi, which is our first quad-core PLC. These devices are a little bit special for us. These are the first Berghof industrial Raspberry Pi based devices. We will provide two variants. One is the BC Pi, standing for box computer with the Raspberry OS, and the next one is the MC Pi from our Benimis MC lineup for modular controller, which will be equipped with a Berghof real-time Linux and CODESYS v3. The basis of these devices is the Compute Module 4, which is equipped with a 1.5 GHz quad core. And also, depending on the variant, we can go up to 4 GB of RAM and 32 GB of onboard flash. 200 kilobyte of retain, an integrated real-time clock, gigabit Ethernet, and a dedicated Ethercut port. We have the option for wireless connection and Bluetooth. We have USB 2 and USB 3 ports. We are equipped with a digital display interface. We have a high performance cooling for passive operation, but also have the option to connect a cooler if you have higher temperature environments to avoid CPU throttling. We also have an option with a bigger extended passive cooler, additionally to the optional cooler if you want to go with even higher ambient temperatures. The devices are fully compatible with our Benimis MCIO portfolio and of course our CCIO if we are going to use an extender. And we can also provide CAN interface via a Benimis extension module that is coming to this lineup and serial ports over USB. Let's take a closer look to the specs of the MC Pi. As I already said, it comes equipped with our proved and tested real-time Linux together with the CODESYS Multicore runtime. We will support all the features that you already know from our controllers that are CODESYS v3 based, and there will be two variants, the Pro and the Prime. They differentiate basically in their size and their interfaces. So we have the Pro variant with either 1 GB or 2 GB RAM, 8 GB flash, and additionally the Prime also provide 200 kilobyte of retain. We have on both of the devices 1 gigabit Ethernet port, and the Prime is also equipped with 1 fast Ethernet 2-port switch as an extended connection. We have an Ethercut dedicated port. It's on the side that you already might know from our MCIO lineup. Of course, we have USB on the Pro with 1 USB 2.0 and 3.0, and for the Prime with 2 of them. Again, the standard protocols and software that will be included with the MC Pi is the Multicore runtime, the CODESYS target visualization, the Ethercut master, and many more options and protocols available as an option. Let's continue to showcase the CODESYS Multicore and how it is set up, and a little bit of showing. Now, I have showed you the devices. Okay, we have now dual core and quad core CPUs. If you take a little bit look at the market, you can also find for some time different multi-core devices, but here you will always have to be a little bit careful. Okay, the device is is equipped with a quad core or dual core, but is it a real multi-core system? Because not only the hardware here is important to have the multi-core experience, but you will also need a multi-core optimized operation system as well as the multi-core CODESYS runtime. There are 2 runtimes provided by CODESYS, with the multi-core and the single core, and only the multi-core runtime also provide you these features. So even if there are some devices out there that have multi-core for a longer time, they might not be real multi-core devices. For us, of course, we have the hardware, we provide the optimized operation system, as well as our CODESYS runtime that is pre-installed on CODESYS of CODESYS and our Multicore devices is the Multicore runtime. So what options and do I have and how does this look in CODESYS? Here, just a quick overview. I will show this live after this. We have here our task configuration. New is that with a multi-core device inside CODESYS, the multi-core target, I have the options to create task groups. And these task groups then can have different tasks inside them. And I am able to pin these task groups to our different cores via different methods. We have 4 methods that are supported inside CODESYS. We have the fixed pinned. All tasks are bound to one processor core. By default, the runtime system determines the processor core. Sequentially pinned. All tasks are bound to and fixed to a different processor core. The user does not have any influence over this. Free floating, all tasks are bound dynamically to different processor cores. The user does not have any influence over this. The operation system is responsible for the distribution. And we have the core number, which means I select a fixed defined processor core. If the processor core is not available, then an error measure is issued. So even if I take like this can happen if I change between my application between 2 core and 4 core systems, so I get an error. Okay, so much to this. Let's go to the showcase. First of all, I want to show what do you have to check and set inside the PLC itself to get the multi-core experience. I have a device connected here. And as you can see, I am connected right now to an MCPi Prime that is running here beside me. And if you now try to look for some kind like multi-core core distribution, you won't find any option here. The setting that you need to have in mind when going with multi-core is our network settings. And basically, it is the setting on which of my Ethernet interfaces, of my main Ethernet interfaces, not the virtual ones here, I have selected Ethercut as a mode option. Because as soon as I select Ethercut as a mode, this interface is pinned directly to the last core available on the system, which means, okay, if I have a dual core system, it's core 1, the core count always starts at 0. Or if I go with a quad core system, it is core 3. And this is basically what you need to know. So as soon as I select Ethercut here, this interface will be pinned to the last core available on the system. You need to have this in mind, because when you go into CODESYS, you will have to do the same with the Ethercut task or with the other tasks that are in direct need of the Ethercut communication. So it's only the Ethercut. Now here on the MCPi, because I have a dedicated Ethercut port, this is my Ethernet 1. It is pre-selected, so this Ethernet 1 port is always pinned to core 3. Otherwise, if for other devices like the CC Prime, if you don't want to use Ethercut, it's no problem. You can release the connection or the interface from the core just by going from Ethercut to either static or a non-configured mode like DHCP or Profinet device. And by that, you will release the core and you will be able to provide then and distribute the cores and CODESYS to your liking, only if you don't need Ethercut. So here it is already pre-selected. I don't have to change anything. Otherwise, you select your Ethercut mode, you press save, and then reboot your PLC. and it will then, with the reboot, start with the pinned core. This is it for the main settings that I have to do inside the PLC itself. I don't need to do anything more. And let's now jump to CODESYS. Just as a showcase, I have here one demo with a CNC program that has 4 axes. Now this is divided between 2 real axes and 2 virtual axes and is running here beside me. This is a single core CPU here, and I only have, you can see here, 1 task group. And if I just take a look at my monitor, I have my runtimes and how it is provided, and I have the information which core is used. Of course, here it's always core 0 because I don't have any more cores. I can see here my average cycle time of around 280, 300, and the jitter of around plus minus 100 microseconds. So I log out here now, and I will just open a second project. This second project is identical to the project I just showed you, but with one difference. I have already pre-configured it hardware-wise to be the MCPI and with the Ethercut connection. Otherwise, if I go into my task configuration, and this is basically what I need to do, I need to work on my task configuration. The settings are the same. So I have not any additional task groups, and I have not set any cores to be fixed or to be connected. So the first step that I need to do now, as I'm using Ethercut, I have to create at least one additional task group. Going inside here and naming it Ethercut. And then I just drag and drop here the Ethercut task down to the Ethercut task group, and I select here my core 3. So this is the most important setting that I have to do as I'm using Ethercut. And now, depending, of course, on the application, I can go either way. So I have 2, 3 more tasks here. Yes, I could also now go and create 4 task groups and use 1 task group each for 1 core. Or I could say everything else is not really real-time prioritized. I don't need special timing. The system should do it for me. I can select here free floating, and I have here for my first test, for my basic setting, some basic setup. Of course, you're able to optimize it to your liking. It always depends on what you need to do. One thing that you have to be aware of when going with when changing from single core to multi-core devices is that you have real multitasking and real parallelism. So even if you have a single core device and you change it with priorities and semaphores and things like that, you still have some kind of serial working through all the tasks. Here, I don't have, like, my higher priority task is interrupting the lower priority, running through, and then it's running parallelly. So here this one is running, and these 3 will also run. It's very important to know, especially if you have different tasks that access different or the same variables from different cores. It might be very easy that you come into a rage condition. So you will not really know which task right now is writing my variable, and you will have to search for it. This is like the most usual trap you can fall in when changing to a multi-core device. So this is something that you need to be careful of. You might need to use like some state machines to lock the different states between the different cores and the different tasks, or using semaphores, or of course your task and the options are more or less independent from one another. So only one task writes all the tasks, and all the other tasks, if they just react, you're free to go. Like in this case, I will set it here to free floating and to Ethercut 3, and that's basically it. The only thing that I need to do now is download the application, and one more step that I have to do is I just have to plug in the Ethercut drives to the MCPI. Just give me a minute here. And I've done this. I go to my device, I scan it, I select it, and I say download. No application was running right now here. I say download. Now it's a little bit like reworking, compiling, generating code, and the download will now start. And I'm ready to go. I'm waiting. I can see that my drives already started. And if I go to my task configuration now, after the boot up, if you want to have valid results, always do a small reset. And I go to my visualization and I start my CNC progress. You will see here now it's preparing with the preparation tab. Or first, it's reading the CNC file. We are the file task, and then it is preparing the file. And right now the drive is homing, and you can see here by changing in synchronized motion, my CNC process has started. Everything okay? And if I take a look now at my cycle times, I can see here, of course, because it's multi-core and because of the higher clock rate, I have almost 3 times or about 3 times faster average cycle time and half of the jitter that was on the single core system. The results may vary depending on what you're doing, of course. When going with dual core, and if you have a millisecond task, of course, like here, the task for the Ethercut was millisecond. It was also the same for the single core. If I log into the single core here, also millisecond. You might not be able to increase, if you're going from single core to the dual core, to increase your average cycle time, because of course when you go in millisecond and you have only low or less important task running, you will get your average cycle time. And if you go to your dual core, the cycle time might not go down, but what will go down, it's because of the better distribution, is the jitter. And of course, the load that is on one core will be distributed among 2 cores. Just like to take a look about the CPU load now here, how does it look? I have an average load here of 7%. On my other cores, I have 3, and 22% on my core 3, where my Ethercut is running. But not only my Ethercut, inside my Ethercut is also, of course, my CNC application. And this is how you can take a look on how it's going. And here you can see, yes, it's going very slow. It's not very well optimized. The scaling of the drives, I have to say, is just a showcase. But this is how it looks like. So that's it for the showcase. I thank you very much for your attention. If you have any questions, feel free to contact the technical support, which is me, or just approach your sales manager, either Mr. Matthias Geisler, Mr. Mark Skoters, or Mr. Raphael Wall. They will be happy to provide any information, or they might even approach you about these new devices soon. Thank you very much again, and I wish you a nice day.